Perms and comms, factorial notation. Now, today we are talking about this thing here, the exclamation mark. Now, the exclamation mark is after it follows a number, it means take all of those numbers and multiply by the one less than it, then the less than that, then the less than that, the less, all the way to 1. So 6 factorial is the same thing as 6 times 4 times 3 times 2 times 1. Okay? So whatever number I give you, 3 factorial, it means 3 times 2 times 1. 4 factorial means 4 times 3 times 2 times 1. Okay? So you can put either one in your calculator. One is just more time sensitive. Okay? Because as you guys saw yesterday in the test, that was another thing. I challenged all of you to be done that in a half hour. And the day before, I gave you 2 examples that a lot of you wasted 10 minutes doing it kind of the long way and never got the right answer. And I showed you how you could have done it in 1 minute using your calculator. So I kind of got you in the mindset, use your calculator, and people said they were able to use their calculator for all the multiple choice, right? That's fast. That gets things really fast. I had one person in the first class. I didn't see much in the second. It was done, multiple choice in 10 minutes. Right? Now, look how much time you had for the rest of the test. Okay? And that comes in handy when that one question you can't get, that one stupid question I just can't get, and you keep looking up and you're like, okay, I still got a half an hour. I can go through this. Okay? I've done the other things. I've tested every one 3 times. They're all right. I'm just going to work on this last question. Okay? And then it's a good feeling when you get it before you leave. Okay? So it's not one of those, I don't get it, so I'm going to leave it and I'll never look at it or whatever, right? And it's just that strategy. If you are better at your multiple choice, you will be able to have more time on your written. Now, one thing that you need to know is that, of course, this equals this. Okay? We just went through that. But 2 times 1 is the same thing as 2 factorial. So I can go 6 times 5 times 4 times 3 times 2 factorial. Well, 3 factorial is the same thing as 3 times 2 factorial. And 4 factorial is the same thing as 4 times 3 factorial. Because what is 4 times 3 factorial? It is 4 times 3 times 2 times 1. Well, that's 4 factorial. So 6 factorial can be written as 6 times 5 factorial, which means 6 times 5 times 4 times 3 times 2 times 1. Okay? Now, again, this may seem like why? Why do we need to do this? And I'm going to show you why this comes in handy. If we look at the next question, 6 factorial divided by 4 factorial. Now, you have this wonderful button in your calculator that does that little factorial thing for you. You can go 6 exclamation mark. Who knows where it is? Math? How do you guys find these things? Okay, so instead of going over, I can just go left. See, I just saved like 1 second. If they all add up, okay, then I'm going to go down to here. Now, one thing that's really frustrating about this is you always have to put in the number first, and then you go there. So it only takes you about 138 times to do it wrong, and then you're going to be like, oh crap, got to put the number in first, okay? Because you're going to see that factorial question. You're like, oh, go to factorial, and you're going to be there, and like, what does that mean? Okay? So then you got to clear it, you're like, oh crap. So then I got to go 6, math, head over there, head to 4. That's 6 times 5 times 4 times 3 times 2 times 1. That's the answer, 720. Okay? But can I do it without my calculator? Now again, you're saying, but I have a calculator, so why do I have to learn to do it without a calculator? Because I can put N's and A's and B's and C's in there and really mess with your head if you don't know how these work. Because the A's and B's and C's in your calculator, they don't do what they need you to do here. Because you can do 6 factorial is the same thing as 6 times 5 times 4 factorial, right? Does everyone agree with that? Now, over 4 factorial. So I'm doing this question here. Now, why did I do that? Because then I can cancel these, and then my answer would be 30. Now again, why would you need your calculator for this? Well, if it was me and I was doing, say, a quiz, I'd probably give you this question. 72 factorial over 70 factorial. Okay, try that in your calculator. See if you can do it. And the answer is overflow. What does overflow mean? What does it mean if you're in a boat? It's not good. Okay? Overflow means, whoa, that's way too big, can't do it. See, now I'm saying this would be a good question to have on a quiz slash test slash diploma, because you'd have to know how to do factorials. What does 72 factorial mean? What's another way to write that? 72 times 71 times 70 factorial, right? All divided by 70 factorial. Okay, these would cancel. What's 72 times 71? Okay, I even had a student after last class explain to me why it doesn't work in your calculator. Why can your calculator not get the answer 512? So your calculator does not do what we just did. Your calculator does 72 factorial divided by, now 72 factorial is way too big for it. So when I say divided by 70 factorial, it's done, it's stopped, because 72 factorial is too big for it. So your calculator does not have this program built into it. It knows how to do 72 factorial. Well, actually, it knows how to, it just can't do the rest. So it knows how to do factorials, but not big ones. It just is too big for the memory, for the unit itself, okay? Now, let's just do a couple of these without using our calculator. What's 10 factorial over 7 factorial? Now remember, that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 1, right? Over 7 times 6 times, okay? But we could write that as 10 times 9 times 8 times 7 factorial all over 7 factorial. Those would cancel. 10 times 9 is 90 times 8, 720. Okay, what about the next one? I've got 8 factorial over 5 factorial, 3 factorial. Any takers? Yep. Okay, so 3 factorial is 3 times 2 times 1. So do you see that these two cancel? Because 6 is 3 factorial. 3 times 2 times 1. Yeah. See, 3 factorial equals 6. Those are called synonyms in mathematics, right? 3 factorial, 6. See now when it's like, you know, I'll have to use it in May now, but if it's May 6th, I can put May 3 factorial. So what would be the answer? What's the answer? 56. Now, here is the if you have n factorial, it means n times n minus 1 times n minus 2 times n minus 3 all the way to 1. It always finishes with 1. And the n's must always be whole numbers, okay? So, and 0 factorial equals 1. You need to know that. 0 factorial always means 1. And I can prove it later if you like. We'll see how time goes. Okay? Now, n factorial is the same thing as n times n minus 1 factorial. Okay? So if you're starting to lose the, whoa, too many n's, 10 factorial would be the same thing as 10 times 9 factorial. Because that's 10 times 9 times 8 times 7 times, well, that is 10 factorial. Okay? 10 factorial would also equal 10 times 9 times 8 factorial, which is n times n minus 1 times n minus 2. And it can also be n minus 1, n minus 2, n minus 3, etc. Okay? Will always end in 1. Okay, let's do these next ones. Let's do complete this. N factorial would be what times n minus 1 factorial? N. N plus 2 factorial would be equal what times n factorial? If n plus 2, what is the next one beside it? So n plus 2 times n plus 1. They must always go down by one number every time. See, n plus 2 is 1 more than n plus 1. They will always go 5, 4, 3, 2, 1. N minus 1, n minus 2, n minus 3. Okay? So what does this equal? Yep. Yes. It's the ending of every factorial. So what would this one be? N minus 3? No. Okay. What does 10 factorial mean? It means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, dot, 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 all the way to 1, right? What is this one then? N minus 4 factorial. See, no one could get it until I did just a numerical example beside. So feel free to do that when you do a test. When you do your study sheet, maybe you want to have one of these. How many am I going to catch tomorrow that don't have a study sheet? You will see. It's good. It really, now those are lowering your marks, you guys. So you may be kicking butt on the exam now that it's done, and that's awesome. That's what I want, right? But you could do yourself a favor by getting good marks on your quizzes, and that's another thing. The quiz marks were by far the best on this unit than all the rest, right? So it is just one of those units that if you know it, it's an easy unit. Okay, let's start solving these now. What if you were just given a simple question like this? N plus 2 factorial over n factorial. What would be the answer? So your calculator's not saving you now, but you could put a number in there like 3 and check it in your calculator after. Okay? Now, one of those, the bigger one, count it down until it looks like the smaller one. Now, what's bigger? N plus 2 factorial, n factorial? N plus 2. So let's count it down. So what is n plus 2 factorial if I count it down? What's the first number? N plus 2, oops, times n plus 1 times n factorial, right? All over n factorial. So that's just n plus 2 times n plus 1. That's what that means. Okay? B, yep. You could just always check if it's multiple choice, right? We'll just leave it like that. Okay, in B, which one is bigger? The bottom. So make it count down. Because if you count down the smaller one, it will never look like the bigger one. It's pretty deep, but you'll get it soon. Okay? So which number would come after n minus 1? N minus 2. So this is n minus 2 factorial over n minus 1 times n minus 2 factorial. Now you've got to grasp this concept that you see that is 1 less than it. N minus 2 is 1 more less than n minus 1. And that's how you always count down. When I say, what's the number after 10? You should be thinking 1 less than it. What's the number after n minus 1? You should be thinking 1 less than it. If you put n there, no, n's bigger. You don't go 10, 11, 12. And then, so this would be 1 over n minus 1. Okay. C, top or bottom, which is bigger? The top's bigger. So let's rewrite the top. Just count down. The first number would be n. What would be the next one? N minus 1. Now, should I just stop there? If I stop there, I have to put that. Can I do this? An n minus 1 factorial does not cancel out with an n minus 1. They're very different. I'll just tell you right now that 5 factorial does not equal 5. So n factorial, yep. Yeah, well, why don't we just do it again right now and just change this to n minus 2 factorial. Then cross out, right? So n minus 2 factorial is my answer. Okay, now here is a question that you're going to have to be able to know how to do the above. If I had n factorial over n minus 2 factorial, this is an easier question. I mean, you might even be able to guess and test for a while and figure that one out. Okay, but let's use our knowledge of canceling. Which one is bigger? Top. So I can rewrite the top as n times n minus 1 times n minus 2 factorial all over n minus 2 factorial, and that equals 42. Right? And I cross that out. So now I have n times n minus 1 equals 42. Some people might even be able to guess and test from here. But let's multiply this out. This is n squared minus 1n. And I'm going to bring the 42 over to become minus 42 equals 0. Okay, so that last unit's still coming in a bit, right? Now, I'm looking for two things that add to negative 1 but multiply to give me negative 42. N minus 7, n plus 6. So what does n equal? 7. Why not negative 6? Why can't you have a negative? Okay, so then you're going to cross that out, not allowed. And if you're smart, you will get that on your study sheet, because in 2 months, you see how I keep shortening my date, it used to be 3 months, but in a couple months, you'll have to try to remember that again, and you may not. And those are the things that kill you. It's the little things, right? Because it could be as simple as n equals -6, b, n equals 7, c, n equals 7 and -6, and you pick it. Okay? Next one. Okay. We've done all this. We don't need to... Okay. Now, let's talk about permutations. Now, permutations, I've kind of already given the ending to this movie. It will only be used when the order of the arrangement of the digits is important. A permutation is an arrangement of the set of elements which order is important. Okay, so we're going to be learning about perms today, permutations, in higher, greater detail than we did last day. Now, here's just an example. We're going to come up here. John cannot remember his access code, except that it contains the digits 3, 5, and 9. Now, 3, 5, 7. What would be the possibilities he should try? What are they? Because you got to keep them organized. I got to list them all. So what would the first two that you would try? 3, 5, 7 and 3, 7, 5. What would be the next one you would do? 5, 3, 7 or 5, 7, 3. Next one? 7, 3, 5 and 7, 5, 3. Okay, so there would be 6 different groups. Okay, now those are considered a group. And the challenge for you is to have a system to keep those straight. A, so you get them all, and B, so you don't duplicate. There's one over here and one over here that are both the same. You're not going to find those. You're not going to see that they're both the same. So do you have a system in place? And you can see someone had the system. I'm going to use the 3s first, then do the other 2. Then I'm going to try with 5s first, do the other 2. And then I'm going to try with the 7th first and do the other 2. Okay? That would be your system of organizing. Okay? So that would be 6 different arrangements or 6 different groups. Now, let's talk about n different arrangements taken n at a time. Now, that sounds complicated, but these ones are quite easy, because if you have 3 things, and I'm making groups of 3, so let's think about the word cat. Now, if I'm going to make arrangements with, there's 3 letters, and I'm going to make 3-letter arrangements, that means I'm taking n objects, and I'm making groups of n. So I'm taking 3 objects, and I'm making groups of 3. Okay, my 3 objects are C, A, and T. So what would be my arrangements? Okay, don't forget that one. The next one. Okay, then the next one. ACT and ATC, and the last one. TAC and... Okay, so this is one way you can do this question. What is... Now, the other way, whenever you take n objects, n at a time, you can also do, since there's 3 objects, you can just go 3 factorial. Now, what is 3 factorial? 6. There's another way you can do it. You can use the fundamental, so that's the second way. The third way is you could use the fundamental counting principle that we learned last how many classes ago? Is I have 3 objects, 1, 2, 3. How many choices do I have for the first pick? 3. The second one, 2, and the third one, 1. So then I get 3 times 2 times 1 is 6. The fourth way is I can use, actually there's 5 ways. but we won't get into that. The fourth way is to use the permutation button in your calculator. The permutation button you would use it like this, 3p3. That is 3 objects that I'm going to pick groups of 3. So with 3 objects, I'm going to pick groups of 3. So, again, go to your calculator. Let's all do it together. Is you hit the 3 first. Then you go math, go left, and go to number 2. And hit 3 again. That means 3 pick 3. So I use the P. The P doesn't mean pick, but that's how I use it. 3 objects, I'm going to pick 3s. Maybe I've got 10 objects that I'm going to pick 3s. That's a little later. But 3 pick 3 equals 6. Okay? So I find that when I'm doing permutations, I find to me this the most valuable. Okay? It is the one that makes sense. 3 factorial, just a trick. Obviously, number 1 makes sense too, hopefully. 1 can be very time-consuming when I'm taking 10 things and I'm doing groups of 10. You're into a little bit of work. You might get 1 question done on your exam. Okay? So, obviously, 1 is extremely inefficient. 3 is, I believe, a combination of efficiency and understanding. Okay? Now, if I was to take all of these letters in the word vagina and see how many groups I could get, this would be 6 factorial, or 6p6, which is 720. Kelowna, see, I'm using all of them. And it is inferred there is no repeats. Because if I'm taking these words Kelowna, and I'm making different words with them, is it possible to have duplicates? It's not, because I already used the E's, so I don't want to have any more E's. So how would you do B? How would you do it? 7 factorial or 7p7, and you'll get the answer 5040. Okay, now let's talk about a more realistic example. What if I'm going to take all the letters of graphite and I'm going to make 3-letter arrangements? Now, always count, first of all, how many letters you're dealing with. How many is that? 8. And I'm making 3-letter arrangements. Now, to me, I would use the fundamental counting principle for this. Okay? So you're not going to see the fundamental counting principle done in every question in your book when you do perms. And it only works for permutation. Fundamental counting principle does not work for combinations. But that's a later story. Now, how would I do this using what I learned? Because you did this question 3 days ago or 4 days ago. How would I do it? 3 little slots. How many choices for the first one? Second one? Third one? 6. So 8 times 7 times 6 is 336. Now, 8 factorial would not work for this one. Do you see that? Only when I'm picking 8 out of those letters. But this would be 8p3. Okay, so just try that in your calculator. 8p3. And you'll get it too. Now there's 2 pretty solid ways to be able to find that answer. One is understanding, the other one is using. You have a question? Okay. Now you can also use this formula here. Now this formula is on your study sheet. sheet, your formula sheet. So you will have to know how to use this formula. Now, this formula right here, that thing's in your calculator, but how am I going to do that? Now, if I was doing 8, the same one above, 8p3. Now, do you see where n's are in the formula and r's are in the formula and the n and the r? Just substitute them. So this would be 8 factorial over n is 8 minus 3 factorial, which equals 8 factorial over 5 factorial, right? Now, how do I cancel the 5 factorial on the bottom? Good. This would be 8 times 7 times 6 times 5 factorial over 5 factorial. These cancel, and guess what I'm left with? 8 times 7 times 6, which is what I had here. And you still get 336. So that's how that formula works. Okay, over here, remember 0 factorial has a factor of 1. If you ever forget that, put 0 factorial equals in your button, in your calculator, and get the answer. Okay, now let's learn how to use that permutation button by doing this question here. In a region, vehicle license plate consists of 2 different letters followed by 4 digits. There are some restrictions though. The letters I, O, Y, and Z are not used. Determine how many different license plates are possible. Now let's do the fundamental counting principle, which gets me out of most trouble. Okay? Now, how many slots am I going to do? 6. 1, 2, 3, 4, 5, 6. What would I use to find, how many choices do I have for the first blank? 22. The second blank. Okay. Now how about the third blank? 10. Next one. 10 or 9? Different digits. That is inferred. No repeats. 9, 8, 7. Okay, and you get 2,328,480. Okay? The answer is the easiest part of this. We all know how to put that in our calculator. It's getting that. Now, how can I write it as a permutation? Now, what you want to do is you want to take it as this group times this group. Do a permutation for the first one. How would you do this in a permutation? What P what? No. 22P2. If you have 22 objects and I'm picking groups of 2. Now do you see how if I had 2 objects I could not pick 22s, right? So that right number can never be bigger than the left one. It's impossible. If you have 5 cupcakes, pick groups of 6s. It's like, huh? Right? Okay, so now that's that times what P what? 10P4. Very good. Okay, let's do this last one. What if I have n minus 1 P2 equals 90? What are some ways or options to figure this out? Yeah, put it in the other form. Excellent. What is that other form? That's that thing on your formula sheet. NPR equals n factorial over n minus r factorial. Okay? Now, all of that is going to equal 90. Now, what you want to do is you want to see here, all you're going to do in the formula is wherever you see n, replace it with n minus 1s. And wherever you see r's, replace them with 2's. So that would be n minus 1 factorial, because n gets replaced with n minus 1, all over n minus 1 minus 2 factorial. And this all equals 90, remember. Okay, now let's simplify that fraction a little bit. That's n minus 1 factorial over what? N minus 3 factorial, right? Negative 1 minus 2 equals negative 3. Now, which one's bigger? Top one. So I could change that to n minus 1 times n minus 2 times n minus 3 factorial all over n minus 3 factorial. And those cancel. So now I have 90 equals n minus 1 times n minus 2. Now, I've got to get this equaling 0 so I can find what n is, right? So I'm going to have to multiply that out. That's n squared minus 3n plus 2. Okay, I just FOILed it. Now I've got to bring that 90 over, so 0 equals n squared minus 3n. The 90 is going to come over and become a negative 90, plus the 2 is negative 88. So I'm looking for two things that add to give me negative 3, and when I multiply equals negative 88. Negative 11 and n minus 11, n plus 8. So n equals 11 or negative 8. And can't be negative 8 because n must be a whole number. Now, I did find a way you could do these in your calculator. Okay, so maybe you want to try that out with me. All you want to do is, in y1, put in x minus 1 in brackets, then the perm button, followed by a 2. Okay, so everybody try it because there is a couple little quirks in it, right? So it's not. So this is what you should have. X minus 1 P2. Okay, and what do you get when you hit graph? You should get that. So graphing doesn't work, but if you go to second graph, it gives you when x is, now do you see when x, all these negatives is not even allowed? But when I put in 0, why is 0 not allowed? What does 0 stand for? X, right? So that would give me minus 1 over there. And then these don't work. They actually, like, you can't have your group size bigger than, so when it's 3, it's 2p2, and you get two choices. But you just cruise along till you see the answer 90, which is n equals 11, or x equals 11. So you can use your table. Okay, so you use table, and then you'll get x equal 11. Now remember, what would be the actual permutation that gives you 11? Or sorry, that gives you 90? What p what gives you 90? 10 p2 equals 90, right? Because remember, that's x minus 1, x minus 11, or sorry, 11 minus 1 is 10. Okay, so even when you're checking them, make sure you actually remember what n equals. Okay, so you'll find that this goes very quick. 1 to 11 ACE and 12 to 15.